Hi everybody, this is Todd Frazee, and this is the first video in the series for your Weld 66 class, and we will be modeling the part from the Titan series to the first configuration, which is TITAN-1-1M, and it's on the first sheet of the drawing with that title. It's pretty simple. It's a block, but you're probably new to Fusion, so we'll go through the steps here to model this part. So Fusion is a solid modeling package and relies on generating sketches in 2 dimensions for the most part, and using tools to take those sketches and create a 3-dimensional object. A 2D sketch, we're going to start off. You need to be in model mode, and if you have a data panel here, you can minimize it so you have more space here. And you're going to select Create Sketch. And a sketch is dependent on a 2D sketch is dependent on a plane. So what we'll display is the X, Y, Z planes that you can select. The orientation of the model is displayed over here right on the right, where you have the axis symbol and top, front, right. Your display may have different letters in different directions, and that's fine. When it comes to the machining side of things, we will be resetting the axes in orientation of the machine, which we're going to be making the part in. I'm going to go ahead and select the top view, which should be this bottom plane here. And your sketch plane is going to go parallel to what you selected by default. You can still rotate around, and a sketch palette should appear here. We're going to go up and use the 2-point rectangle tool, and we're going to select that tool, and we're going to select on our origin, which is here. So our origin on our Cartesian coordinate systems would be 0, 0, 0 in the XY plane. We're going to select right there for our first point, and then we're going to drag over for our second point. So it creates a rectangle. Now that we've done that, you can see that 2 of the lines are blue and 2 of them are black. And what the black by default is means the geometry is constrained or fully anchored. So because I picked on the origin for the corner, these 2 lines are static and the blue segments are still dynamic. It is best practice to have fully constrained sketches before you go on. Everything you make, if you were to reopen this sketch and move it, your entire model is going to change size. To do so, we are going to go to the sketch menu, and we are going to select sketch dimension. You can also use the hotkey, which is the letter D on the keyboard. And we are going to dimension we're going to dimension the in this view what would be the height and the width. So our drawing says that the height should be 1.9 inches. So we type that in, press the enter key, and then we're going to select on the other dimension. And our overall length was 4 inches. So we're going to type 4.0 and press enter. And if we zoom out, we see that everything is, when it's not highlighted, is turned black. That means it's fixed. This is 1.9 inches long. It's 4 inch. This dimension is 4 inches long. That's now defined, fully constrained. Now we're going to select Stop Sketch, And if we rotate the view, you have a sketch with a rectangle, and it shades it a kind of a beige or yellowish color when you have a fully enclosed entity. And what we're going to do is take that entity and now extrude it to have thickness, because right now it has no thickness. So we're going to select on this extrude icon. If your rectangle wasn't already selected, you're going to select the boundary that you want to extrude. We're going to leave start at profile, and our direction is one side of the profile, and we're going to extrude by a distance. We're going to leave all four of those boxes, or three boxes at default. And our distance, because in this case we're going to extrude down, which is in the opposite direction from this arrow, and our thickness of our part is 3/4 of an inch. We're going to type negative 0.75. Okay, and that gives it thickness. We could have also dragged this wheel around for different directions and back and forth for thickness. And we want to make sure it says create new body. We're creating a new entity, it's a new body, and select OK. Alright, you're about halfway through your first model. What we're going to do is we're just going to put a couple features on here. Our drawing calls that the four corners here, 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 and here have a 10,000ths radius called out. So to do that, we go to the modify menu, and we're going to select fillet. Now technically these are rounds. Fillets are concave, rounds are convex, but there's only one command to make this type of feature. So we're going to select on fillet, or you can use the hotkey F on the keyboard. And it opens up this dialog box, and it's asking what edges do you want to fillet. And we're going to pick the four vertical edges that correspond with our drawing, and our fillet size you enter in the box as 0.01 per the drawing, and you can hit enter. And so we now have a small radius on each of the four corners. Okay, our last feature to make is a 10,000ths edge break. Now, a lot of machine shops would do this manually by hand. So we're going to, on this particular project, on the exterior edges, I want your hand skills to be applied, so we aren't going to model the 10,000ths edge break per the drawing. We will be putting that on by hand after we model the part. We want to make sure that we've saved our part with the proper title, which is TITAN-1-1M. And you're going to save that location in your Weld66 folder and hit save. Alright, and the title should update here. If we were to look in the data panel, and your model should appear here in the data window. If you go to the data panel and go to your folder, which would have your name and Weld66 on it, you'll see it here, and it'll say TITAN-1-1M with an icon. Every time you make major changes and save, the version number will change. So this is the first time it's been saved, and so in this case this model says V1. Alright, and you can continue with the next project in your queue. This completes the lesson for TITAN-1-1M configuration.